In this video, we're going to look at forming and then solving a differential equation. So I picked this question because it's more of a problem solving, a difficult type of question. It tells you the annual rate of increase of a population is equal to 2% of the size of the population. So how do we represent that? Well, it tells you y represents the population and t is the change in time. So the rate of increase of the population is how the population y varies with time, dy by dt. That's what you want to find here. It tells you that it's equal to 2% of the population size, and also that the population is represented by the letter y. So you can say it's equal to 0.02 times y, because that's 2% of the population size. Now that you've done part A, we can now move on to part B. In part B, a little bit of a trick. What you can see here, it's a bit small, but it says ae to the power of 0.02t. The only way we can form 0.02t is if we leave 0.02 on the right hand side, so that when you integrate it with respect to t, you can get 0.02t, if that makes sense. In order to do that, we can divide both sides by y to start with, so 1 over y dy by dt equals 0.02. Now, there is also the example where you can divide by 0.02, and although that is still okay, in this specific question, it wants you to write it in this format, where 0.02 is joined with t. Like I mentioned, if you multiply both sides by dt, so that all the y terms on one side and all the terms that don't have y on the other side, you can then integrate both sides of the expression. And that is what will form 0.02t that we're looking for. We do have a plus c at the end, and then the integral of 1 over y is ln of the modulus of y. A bit of a off topic, but whenever you're integrating something where the numerator is the differential of the denominator, just like it is here. So for example, the differential of y is 1, then the answer will always be ln of the denominator. So like you can see here, it's ln of y. Now, in order to make this into this expression here, actually before that, another student once asked me, when you integrate, don't you end up with two constants? And you do, technically, but this one constant that we've introduced is like the constant that you end up with here, take away the constant that you'll end up with here, if that makes sense. So that's why we'd only include one constant at the end. In order to make it just y here, we're going to apply a power of e to both sides of the expression. When you do that, e to the power of ln y is just equal to y, because there's a rule that a log base a of b, where what you're raising it to the power of matches the base of the logarithm, is just equal to the inside of that logarithm. Ln is the same as log base e, so it's just going to be equal to the inside of that logarithm. Now, the right hand side of this expression, you can write this out as e to the 0.02 plus c. But when you add the powers of indices, that's the same as essentially multiplying by e to the power of c, because we know that when multiplying indices, you add the powers together, and it will lead to the same result. What this question has done here is it's replaced e to the c with the letter capital A, and that's okay to do because e to the c is a constant, and we're just saying something like let a equal e to the c, just to make it match what it says in the question. A bit of an unnecessary step, but it makes it match, again, what it says in the question, so you might as well just do it here. And that's everything that you need to do for this question. So this is what we call a general solution, where we have the constant a, but we don't have like an actual value for it. A particular solution is if it gave you a value of t and y that you can substitute into this expression to then find the value of a. But yeah, that's everything for this question. Be sure to leave a like if the video helped and subscribe. I'd appreciate it a lot. Thanks for watching. I hope this video helped. If you have any tutoring inquiries, be sure to visit my website www.excellineducation.co.uk. It's on the first link in the description too.